We're going to talk about separable differential equations here, and this is the main way that you'll be solving differential equations in this class. There are other types of differential equations that are solved using different skills, but this is the main one for this class. So a separable differential equation is any equation that takes the form of, I'm just going to move that so I can see, dy over dx equals f of x times g of x, or dy over dx, sorry, g of y. F of y times g of y, or f of x over g of y, or for sake of completion, we'll draw the last one, dy by dx equals g of y over f of x. So in other words, it's some function of f or of x times or divided by, or 1 over divided by gy. And this is because it can be rewritten as the following: gy, some function g of y, times dy is equal to some function f of x times dx. Now it might be 1 over gy or 1 over f of x, but that's fine. The point is, all of the x stuff is on one side, all of the y stuff is on the other side. And so to solve, you're going to separate the variables, like we have it up here, and then integrate both sides. And if you integrate both sides, you end up with some function of x on one side, some function of y on the other, and that gives you either directly a function or an implied function, a function in implicit form that you can work with. So let's look at an example here. So find the general solution for y prime is equal to the quantity x squared minus 4 minus 3, or times 3y plus 2. So this takes the form dy over dx is equal to x squared minus 4 times 3y plus 2. So I can rearrange this to get 1 over 3y plus 2 dy is equal to x squared minus 4 dx. So if we integrate both sides, we get the integral of 1 over 3y plus 2 dy is equal to the integral of x squared minus 4 dx. Now this 1 over 3y plus 2 dy, when we did the long division section or the partial fraction decomposition section, we found the shortcut there. We can write this as 1/3 ln absolute value 3y plus 2 plus c. If you need to go back and review that, go ahead and do that. We have this, let me just double check, yes. And I'll put a little y here for a second, for a reason that'll become clear later. And the right side, we get 1/3 x cubed minus 4x plus cx. Again, just simple, straightforward integration. Now, cy and cx are because each of these integrals have their own constant of integration. And those constants can be any arbitrary number. They don't have to be the same. So we don't want to call them or think about them both as c being the same value, right? Because the left side, it's completely separate integral than the right side. So those constants of integrations may be the same number. They may be different numbers. They may both be, 0. We don't know. But the point is that we can combine them on one side. So I can move this c over and end up with the function 1/3 ln 3y plus 2 equals 1/3 x cubed minus 4x plus some new constant c, where technically this constant c is equal to cx minus cy, but we don't care what cx and cy are. All we care about is the constant when we finally get to the end of the kind of simplification here. So what you're going to see a lot of in solving differential equations is just having the constant suck up other constants into it. So whenever we can, we're just going to have it absorb other constants. So then I'm going to multiply both sides by 3, and I'm going to be left with ln of 3y plus 2 is equal to x cubed minus 12x plus, again, it would be plus 3c, but we're going to rewrite that as just c, because it doesn't matter if it's 3 times the c I had before. At the end, I'm just going to find out what that arbitrary constant is anyway, so I can just absorb it in here. Then we'll get the absolute value of 3y plus 2 is equal to e to the x cubed minus 12x plus c, which can also be written as e to the x cubed minus 12x times e to the constant c. Again, because we don't care about the constant, like the individual constant step by step, we're going to rewrite this whole thing as c. And we're going to get 3y plus 2 is equal to c e to the x cubed minus 12x. And that gives us a final form of y equals c e to the x cubed minus 12x plus 2 over 3. The big thing I want to just point out here is that absorption of the constant. Any constant that gets multiplied, added, subtracted, divided to the integration constant can just get sucked up into it. So technically, if you wanted to write this as y equals ce to the x cubed minus 12x plus 2/3, that would also be acceptable by splitting it into, the two fractions and absorbing that 3 into the c for the respective fraction there. What I'm going to do now is break the video, and I'll show you another example of solving a differential equation in the next video.